Pulumi provides us with a very lean yet powerful configuration system. It is split between global project settings and stack-specific configuration that can override any previously specified options. The project configuration is stored in a Pulumi YAML file. Here you can define the project name, description, and runtime. You can also set up a strongly typed configuration schema or customize project structure. By default, Pulumi uses index.ts as the entry point, but you can change this by setting the main property. You can also set a separate directory for storing stack-specific configurations to keep things organized. This is particularly useful if you have multiple stacks and want to avoid cluttering up your project's root directory. There are some funky behaviors when using the main property though that tripped me up a few times. Even though the main prop is supposed to change the entry point, the main prop in package.json actually takes precedence. Check this out. I'm going to create the source index.ts file that I pointed to in Pulumi YAML, and I'll create just a simple S3 bucket here. Now, when I preview the stack, it throws an error because a path to an HTML file is incorrect. But what file? Well, the one in the original index where I actually uploaded. The real funny part is that the path to that file is relative to the main property in the Pulumi YAML. Once I change it, I can preview again and it works. There's more though. If I remove the original file and preview the stack, then it defaults back to the main prop in Pulumi YAML and I can see my bucket now. I've also had issues with zipping folders for lambdas when changing the main prop, so I just stopped doing it to save myself the trouble. As mentioned in the beginning, Pulumi also supports strongly typed configurations. This way, you can ensure that your config values are of the expected type, enforcing consistency across your project, which helps avoid errors and improves maintainability. For me, the most enticing feature here is the secret property for ensuring encrypted values. The scalar types like string, integer, and boolean are somewhat flexible as they are coerced into their type on runtime but are stored as strings when using the Pulumi CLI. I suppose that's not a big deal, but on the other hand, the feature is supposed to add strong typing to the config schema. Coercing the values seems to be missing the point. Then there's the question of maintaining a schema in a YAML file for a large project. Will it be manageable, or is it better to use something like Zod instead? Either way, the schema is validated during runtime anyway, so Pulumi CLI will not validate the value against the schema when we're setting it up. There are also other project config options that may be less common but are useful nonetheless. Template can be used for setting up a project to be used as a template for creating other projects. Backend is used for connecting Pulumi CLI to a custom backend instead of using Pulumi Cloud, and plugins is for those of you that wish to create your own Pulumi plugins and can be used to link to local plugin binaries. It specifies which plugins should be automatically installed when the project is run. It's not mandatory because Pulumi can determine which plugins are needed based on the resources defined in your program. However, you can use it to control the exact version of a plugin or to ensure that a plugin is installed even if it's not directly referenced by any resource in your code. Now let's take a look at how to manage stack configurations with the Pulumi CLI. A Pulumi program can be split into stacks, which are simply a logical separation of concerns, not to be mistaken for stacks in CloudFormation or CDK. A stack in Pulumi includes all the resources in a Pulumi program, not just a subset. It is very straightforward to set config values. For example, to set the AWS region, we use Pulumi config set command and then the property name and its value. You can also set values in more complex structures like arrays or objects using the path option. To use any of these values in the program, we have to create an instance of a Pulumi config class and use one of the provided methods. These are split into two categories. The get methods allow nullable values, and the require methods will throw an error if their value is missing. Each of them also has type-specific helpers. Securing sensitive data is paramount for any application, so you can set secrets using the secret flag and Pulumi will encrypt them for you so that they can be safely included in the config and committed to a remote repository. Understandably, most, if not all dev teams would rather have their own managed key for encrypting data. And for this use case, Pulumi supports AWS KMS, Azure Key Vault, GCP KMS, and HashiCorp Vault. When using AWS, we can choose 3 different ways of specifying the custom provider. The keys ARN, ID, or alias. And we can change it at any time, either when creating a project, creating a new stack, or changing an existing stack's provider. As you may have noticed, we can also add additional data to the encryption context with the context_query params. It can be useful for fine-grained access control and auditing purposes. This shouldn't be sensitive data though, as it is stored as plain text in CloudTrail logs. When changing the secrets provider that already has encrypted secrets, they will be automatically re-encrypted using the new encryption key. You might actually not want to use a third-party provider though, maybe for environments that are ephemeral or just for development. In that case, you can use a passphrase for encrypting secrets. I'm gonna create a new stack, but this time as a secrets provider, I want to use passphrase. Now I'm prompted to enter my super secret password, and that's it. Now if I try to decrypt the secrets, it prompts me to enter that password. One drawback is that this will happen no matter what I try to do with the Pulumi CLI. To avoid having to enter the passphrase every time, we can add a Pulumi config passphrase variable to the shell environment, and now it doesn't prompt anymore. So now let's say I need to create a separate stack for a new feature that I'm working on, but if I create it, the config is empty. The file isn't even created actually. It's gonna use the project configuration defined in Pulumi YAML. Of course, you could manually duplicate the config of a different stack, but you can also use the Pulumi CLI when creating the stack. Notice that the secrets have been migrated and are still encrypted, but the new stack uses the default Pulumi managed key. You can tell because a custom key would also be encrypted and stored in the config file. To create a new stack with a custom provider, we need to specify it in the command. There are about 3 situations that I can think of when we might want or need to decrypt secrets. First, when we actually need to use the value in the program. Second, when we want to check the encrypted values in the config. And third, when there are secrets in the Pulumi output of the Pulumi program. Similar as with normal config values, we can use the config instance to get or require a secret value. And just like before, there are type-specific helpers. For the other 2 situations, we can use the Pulumi CLI and the show secrets flag either with the config or stack command. Aside from the config that is tailored to your project, there are also provider-specific options. If you take a look, all properties in my config are prefixed with my project's name, except for AWS region. This is an option required by the default AWS provider. Any option that can be specified when explicitly defining a provider can also be specified here. To access this value, you can either use the config instance or use a dedicated helper function from the AWS library. There are also 2 options for configuring Pulumi. We can choose to disable selected default providers, ensuring that each provider is explicitly created within the program, or use a wildcard to disable them all. Then there is a tag option for tagging stacks. These tags can be then used for sorting projects in the Pulumi cloud. Even though they are specified in the configuration file and that's where they show up, they actually show up on the stack itself as well, either in the Pulumi cloud or when running Pulumi stack tag ls. As you can see, none of the other config values show up here. That's because Pulumi tag's property is an equivalent of running Pulumi stack tag set command. Okay, so to sum up, Pulumi's configuration system offers a fresh and efficient way to manage project and stack settings compared to traditional environment variables. It allows for detailed configurations via the Pulumi YAML file, supports strongly typed schemas, handles secrets securely, and provides flexibility in setting custom secret providers and organizing stack configurations, all while simplifying management through the Pulumi CLI. That's it for this video. Thanks for watching.